Another example of a power series to be able to determine the interval and radius of convergence. So this one we have -1 to the n, x to the n over 4 to the n. Notice once again, everything's being raised to the nth power. So we can still use the root test on this, all right? So we're starting with the root test because it's a little bit easier. And then once we get to the ratio, it's going to involve a little bit more algebra, okay? So you're going to take the limit as n approaches infinity of the nth root of the absolute value of -1 to the n, and then x to the n over 4 to the n. And we know for that to be convergent that it has to be less than 1. All right, so now what we're going to do is we're going to apply the nth root to everything. So now we get the limit as n approaches infinity, and this n, this n, this n, this n, they're all going to cancel each other out. And we're going to have the absolute value of -1, x over 4 is less than 1. And clearly, if we take the absolute value, right, we can pull this -1 out. So that's just going to cancel out because of the absolute value. And we can pull the 1/4 out. So we can now have the limit as n approaches infinity of 1/4 of x, which is less than 1. And then finally, we can multiply both sides by 4. All right, so we would have that the limit as n approaches infinity of absolute x is less than 4. All right, now, if we apply the limit to this, there is no n. So there's nothing that we have to worry about because n and x are independent of one another. And so this tells us that the absolute value of x is less than 4. And right here, because we've isolated the absolute value, and it's centered about the point x equals 0, all right, we can see that this is going to be the radius of convergence, okay, because that's going to be the distance from the center, okay? So the radius of convergence is equal to 4 for this one, okay? All right, now, and again, that's because we're going to go 4 units left and 4 units right once we found the interval of convergence, okay? So now we have to find the interval. To do that, we're going to split this up, and we're going to say that -4 is less than x is less than 4. So we're just going to use that rule of inequalities, okay? Now, this is the initial interval of convergence, but that means that we have to plug in x equal -4 and x equals +4 back into the original series, okay? And what's going to happen is we're going to see two familiar series that we actually saw in the first video, okay? So when x is equal to -4, we get the series n equals 0 to infinity, -1 to the n, we have 4 to the n, or -4 to the n, excuse me, divided by 4 to the n. Okay, so all I did here was I just substituted 4 back in for this x. All right. And then for the second series, we're going to let x be equal to +4. All right, and so that's going to give us the series n equals 0 to infinity of -1 to the n, 4 to the n over 4 to the n. All right. I'm going to pick on the first series that we just created by substituting x equals -4, because that one's a little bit easier for us to be able to work with, okay, at least with the series test. Now, notice that both of these factors have the nth power. So what I could do is I could rewrite that by algebra and multiply that, okay? So just to make sure that we're okay with the algebra, this becomes -1 times 4, or -4 to the n. All right, so I just multiplied what's inside of the nth powers, divided by 4 to the n, right? Clearly, that just becomes 4 to the n over 4 to the n. This becomes 4 to the n over 4 to the n, which clearly is going to become 1. All right. Now, what happens with this? Okay, well, what's going to happen is if we just keep adding up ones, and this should be n equals 0 to infinity, excuse me. Okay. If we just keep adding up ones, okay, or we could just use the test for divergence. So we would have the limit as n approaches infinity of 1, which is equal to 1, which is not equal to 0. Okay, so this is the test for divergence, then clearly it diverges at x equals -4. Okay. And that's what we just wanted to show, that it diverges here. All right. Now for this one, those cancel out. Right. And if they cancel out, we just have the series n equals 0 to infinity of -1 to the n. And you probably remember in the first video, we actually showed that this was a divergent series by the alternating series test. So by our alternating series test, and I'll just do it again just in case you didn't remember it from the first one. That's an alternating series. And remember, we just need to take the limit as n approaches infinity of the absolute value. Okay, so remember condition 2. We're going to write a sub n, or the absolute value of a sub n is -1 to the n, which is just going to be 1 to the n. All right, and if we take the limit of that sequence of 1 to the n, that's going to be equal to 1 to the infinity, which is not going to be 0. Okay, so clearly that's not equal to 0. Okay, which means that it diverges at the point x equals 4 as well. Okay, and so eventually we will get to some problems where it converges at least one of the endpoints. Okay, but for right now, it just seems like we keep being divergent at the endpoints. Okay, so our interval of convergence is going to be exclusive -4, exclusive +4. And the radius of convergence is going to be r equals 4. Okay, remember we found that all the way back up here. Remember, to find the radius of convergence, you just isolate the absolute value. Okay, all right. So hopefully that shows you all how to go through and be able to find a couple of the interval and radius of convergence for a couple of the easier ones. Okay, not saying that any of these are easy, but at least these are a little bit less algebraically taxing. And now you can see the use of where we use all these the convergence tests for convergence and divergence. Okay, so hopefully in subsequent videos we're going to be able to see some of the ratio test problems, and I believe in the next one we will.